Okay, good evening. Okay, all good now. Okay. So from today onwards, we will be doing the online class. Like we will be not doing, we will be streaming the online class via YouTube. The reason that why I changed the platform is not that I have any personal grudges with Zoom. The thing is, when we do this YouTube live, especially for the online students, it's much easier. Let's say you get late to join to the class, but still, if it is a Zoom meeting, when you go to the class, you have to start from there. But in the YouTube live, you know that you can start from the beginning. And in case if you get late to join the class, that will be advantage. And the next advantage is the recordings that we use is the Zoom recording. And honey, this is even important for you, not only the online students. So here, so the recordings that we use is the Zoom recordings. So the Zoom recordings is like if you do a 4 hour class, that recording is normally compressed up to like 900 MB by Zoom. So you get a auto compressed recording, which is a low quality one. Like if we use the camera recording, the thing is if you do a 4 hour class, we get a 25 GB, 20 to 25 GB output if we use the camera recording. So that is even not possible. So that's why we went with the Zoom recording this far. But now when we do the YouTube recording, YouTube live, we can use the YouTube recording. So then we can edit it and again upload it with a good quality. So everyone here listen, like I have got messages from the admins mentioning that you haven't registered to the website. And 10 minutes before the class, like there are some physical students who are asking, I won't be able to go to the class today. Can I get the Zoom link? Can I get the link? Okay, it's a small, simple thing. What you have to do is first thing you have to get registered to the website. The website is www.myname.lk. My name is not your name. It's my name, mandapanditake.lk. Anna, listen, silence. So register as a 2027 English medium student. And let's say you won't be able to join the physical class today. What you have to do, upload the slip, the monthly slip with given by COChem at least 2 hours before to the class. Because they will be checking till 2:30. They will be checking for students who have uploaded the slip till 2:30. And then like that's why I'm telling you, upload it before 2 hours to the class. And the other thing is, I'm not running behind money. You all know that. So let's say it's in the second week that you haven't still paid the class fee. That is totally okay. You come to the class in the first day and you don't pay the class fee, and then in the second day you get absent. So in that case, that doesn't mean that you won't be able to join to the online class. Then at least upload the September slip. So that can happen. So even in the third week, if that happens, you come to the physical class for the first 2 weeks and you don't pay the fee. So you are missing the class on the third week. So still that's okay. You can upload the September slip. And if you don't have the September slip with you, which normally you don't have even at the beginning of the month, like when it comes midway, you don't have it with you. No? So talk to the admins and tell that you haven't paid the fee, but let me join the online class. So they give access. Okay. So that's a small thing. That's even easier for both then. Then you don't have to even communicate. You don't have to send WhatsApp messages asking for the link. Clear. So like from here onwards, let's do that in that way. It's easier for both of us. Like me, the admins, and even from your end, you have to just upload the slip. And by the class starts, you will get the link. And we will be uploading the YouTube link. Today it got late, but normally by 2:50, we will be uploading the YouTube link. So you can get the YouTube link from Zoom. Sorry, from the website. So it's the same thing. Previously it was a Zoom link. Now it is a YouTube link. The only difference is that. And the previous recordings were Google Drive links, and now the recordings will be even YouTube links. So what we will be doing after doing the live class, there will be the YouTube live for like 2 hours, and after 2 hours we'll be taking it down. So if the class finishes by 7 o'clock, by 9 o'clock we take down the live video, we take it down so you won't be able to watch it again, and then we edit it, and then we will be uploading the edited video to YouTube, and then that link will be pasted in the website. And even though you will share the YouTube link or the recording link, that doesn't mean that anyone can join because it's a private link. The only ones we have given access can join. Even though you get the link, you won't be able to join it if your Gmail haven't been given access. Okay, so make sure you are with the same Gmail that you are using for YouTube, and that is the email address that you have entered to the website. අම්මගේ email එක දාලා ඇවිල්ලා තියෙනවා නම් like within like 2 weeks fix that. So your email address should be the same Gmail that you are using for YouTube because you are getting access for that email. Clear? So you guys are technically way ahead than us. So act like that. Okay. So act like that. You are technically way ahead. So act in that way. Because I have seen messages asking in this way, like, okay, I went to this link and the when you have to upload this link, I have seen messages you are sending to the admin asking, this is great, this is larger than 1 MB. How can I upload it? So you should be technical ahead. If you take a screenshot of that, or like if you screenshot it 2 times, the quality drops and then it becomes less than 1 MB. And once I can remember when the admin has told, take a screenshot and upload that, he has taken a screenshot of the chat and uploaded the chat to the website. So he has sent this slip mentioning I can't upload this. Yeah, this is more than 1 MB. So the admin has to okay, take a screenshot and upload it. So what he has done, he has taken a screenshot of the chat and he has uploaded the chat. And the description is I screenshot එකක් අරගෙන upload කරන්න කිව්වා. So don't do those things. Like act like technically advanced people because you are from the Gen Z. You are from the okay, silence. You are from the silence. You are from the Gen Z. So the Gen Z officially starts from our year, my birth year. The Gen Z officially starts. So like statistically, even though we are in the same generation, but you guys are technically ahead. So act in that way. Are we clear? Okay. තේරෙනවද? සිංහලෙන් කියන්න ඕනද නැහැ? In දෙමළ වලංකින්ච. All good. නල්ල. Okay. සිංහලෙන් කියන්න ඕනද නැහැ? හරි. ආයෙම වෙන්න බෑ. Okay. Okay. So we are done. So we started modulus functions last week, and let's do one example question to remind modulus functions. So I have now asked you to do up to question number 11 for homework. Silence, silence. Hurry, silence. Okay. All good, fix. Yeah. Okay. So I'll do question number 11. Y equals 3 times modulus x minus 2 plus, we have plus 1. We got plus 1. Okay, so how to draw the modulus graph of this? Silence. Who's talking with me? Okay. Oh, silence. Right? So write the definition. It's this directly comes out. This directly comes out, and you get 3x minus 6 plus 1 is minus 5. You get the minus of this. Now silence. So I don't want to get featured by anyone, okay? When I'm talking, let me to do it alone. Featuring artist lepa mata. Silence. Stay in this way. So when it becomes minus, you get minus 3x and we get plus 6 plus 1 is plus 7. So we get this one, this y equals 3x minus 5 when this x minus 2, which is inside the modulus, it's greater or equal to 0. And then when it is greater than 2. We get the minus of that. When x minus 2 is less than 0, that means when x is less than 2. So we get this when x is less than 2. And now when you're supposed to sketch this function, there are two straight lines that you have to draw. One is y equals 3x minus 5. And the other one is y equals minus 3x plus 7. So here, I told you when you are sketching a straight line, you need a minimum of 2 coordinates. But today, in the last phase of the class, I'll be teaching how to draw a straight line using 1 point. How to draw a straight line using 1 point. For now, let's go with 2 points. So 1 point, you already know the intercept. So that you know. And when you're taking the other point, I told you, always find the turning point. So always find the turning point. So when you substitute x equals 2, you get y is equal to 6 minus 1 is 1. So then you get the turning point as 2, 1. Now you know the turning point and you know the intercept, which means you can draw this graph, the straight line. So even here, go with the intercept, the turning point, which is x equals 2. You get y equals plus 1. And then you get this coordinate, it's 2, 1. And now when you have to sketch this, since we have two intercepts, one is going to -5 and the other one is +7. So we'll be needing this +7 and 5. The turning point is this 2. So I'm going to sketch y equals 3x minus 5. So we can mark the intercept as -5. And when x equals 2, it is the y coordinate is 1. Then draw this straight line which goes through these 2 points. Draw this straight line which goes through these 2 points in this way. But I know when you sketch this, you know that this is only valid when x is greater than, this is only valid when x is greater than 2. So this is only valid when x is greater than 2, which means this part is not valid. You can take it out. You can either completely erase it or you can use a dotted line. And now since you have experience, like I don't expect you to draw this using a pencil and then erase this, make these dotted lines. Because when you are drawing this, before drawing this straight line, you already know that this is only valid when x is greater than 2. Clear? You know that is only valid when x is greater than 2. So what you can do is you can use a ruler, not the COCM ID. You can use a ruler, keep the ruler joining these 2 points, and without drawing this line, you can just continue the line from here. So you can do that. Clear? So you can keep the ruler. I don't have a ruler to show that. Do we have a substitute for a ruler? We got a substitute. Wait. Okay. So I need a help from a friend who got me. Any volunteer? Just come on. 1 minute, come in. Yeah, you're going to be on YouTube. Come. Okay, so give him a clap. So he volunteered. Good. Okay, so what? So this is what I want you to do. So hold these, join in these 2 points. Okay, from this side. So what you have to do is in this way. Can you see? How you can see the video? Okay. So here, so you have to keep the ruler in these 2 points, and then what you can do is you know that this is only valid after x equals 2. So then keep these 2 points and then join in this one. You can draw the straight line in this way. So even the same thing, when you repeat it to the other side. Okay, so then we know that it is going through, pointing marker. It's going through this point 2, 1. Okay, it's going through this point 2, 1. And then we have to mark the intercept. The intercept is +7. So I'll take intercept as +7. So now what we have to do, we have to join these 2 lines. Okay, now he'll be keeping the ruler, joining these 2 lines. And then even though the straight line continues, can you see? Okay, so going this way, I know this is only valid from here. So what you have to do is draw the line only from here. Clear? So then we can get the awesome. Okay, nice. Okay, so give him a clap. Okay. But Fana do then no Kaurutavena is the only one who volunteered. Okay, so then you can do that. Okay, silence. Back to the lesson. So then you can do in that way. Then you don't have to draw this using a pencil and then make it a dotted line. Or like if you're drawing with a pen, you can do it in the same way. So always name this. So this is y equals -3x plus 7. So I just reminded how to do this. So this one gives you this V-shaped graph is the graph of y equals 3 times modulus x minus 2 plus 1. This V-shaped. Got it? Okay. So then do question number 12 based on the definition of modulus functions. To question number 12. So you have done up to question number 11. Okay, now silence, silence. Okay, silence. To question number 12. කතා නවත්තන්න. First write the definition using the definition. There can be a noise when I have given some work. Okay, so question number 12. We got is y equals minus modulus x. So you know how to write the definition. That you know. Stop talking. Okay. So how did we write the definition? This minus modulus x. It became x, but since there was a minus, it's minus x. You get this when x is a positive 1. So what happened here is modulus is x becomes x, but since there's a minus, it becomes minus. So here it's minus minus x when x is less than 0. And then this gives you x. So what are the straight lines that you're supposed to sketch? It's y equals x and y equals minus x. So I'll draw it directly because we have already drawn the graph of y equals x and y equals minus x previously in question number 1. So I'll be directly drawing this in the same way that I used. Okay, now what happens here? First, I'm sketching the graph of y equals x. It goes in this way. The y-axis, the x-axis, we have the origin. And it is a graph that is going through the origin with a positive gradient. With a positive gradient. So this is y equals x. And then the next one is y equals minus x. It goes in this way. With a negative gradient, we got y equals minus x. But now, most of the students, even though I haven't looked at your books, I'm pretty sure what you have done, based on what you have drawn so far, you consider, okay, this is valid only after this, and this is valid only before this. And then you name this as y equals minus modulus x. Okay, so be honest and hands up if you have done this. Okay, so what is the reason that you have done this? Because you saw every modulus graph that we have sketched is having a V-shaped graph. But the thing here is, if you look at this function, the straight line, this is y equals x. But tell me y equals x is only valid when x is less than 0. So you get y equals x when x is less than 0. It's less than 0, which means this straight line is only valid when x is less than 0. So what cancel off is this part. This is the part that we are missing because y equals x is only valid when x is less than 0. Okay, then this is y equals x. Same thing, y equals minus x is only valid when x is greater than 0, which means you won't get this part. You won't get this part. So this is y equals minus x. So this is not a V-shaped graph. This gives you the graph of y equals minus modulus x. Clear. So then we have to understood that the modulus function or the graph is not always having a V shape. It can be a reverse V shape, and there are different shapes. Even we will be getting these kinds of graphs, this way, V-shaped, this graph, different graphs. So here, at the end, you get this. But there is one point that you can keep in mind. When we are having a minus in front of the modulus, we get this shape. Mostly we get this shape. So we can say every graph consists in a minus in front of the modulus, you get this one. But most of the modulus functions where we have a minus in front of the modulus part, you will be getting the opposite of this V, this shape graph. Clear? Hands up if this is clear. Okay, then everyone do question number 13. Question number 13. Okay, so what we got as question number 13 is y equals 2 minus modulus x. So first write the definition, and the definition gives you a 2 minus, this comes in the exact way, so minus x when x is a positive number, you get the minus of it. So then you get 2 plus x when x is a negative number. So what are the straight lines you got to sketch? So it's easier when you draw this, write it in the format of y equals mx plus c. Then it is clear, okay, this is having a minus gradient and the intercept of plus 2. So when you are writing this, write it in the format of y equals mx plus c. And the next one is y equals x plus 2. So you are supposed to sketch these two graphs. You already know the intercept, and we got a similar situation even before. When you go with the turning point x equals 0, you get the same intercept. So in that case, you can consider another point because you have already taken the turning point. We take the intercept, but even when you put x equals 0, you are getting the same value. So here the intercept is the turning point. So then you can go with another value. If you go with x equals 1, you get y is equal to 1. So it will be going through the point 1 and 1. And here, if you go with x equals 1, you get y is equal to 3, which means it's going through the point 1 and 3. So then you can sketch the graph. The turning point is 0. So sketch the two graphs. Y equals minus x plus 2. The intercept is plus 2. And when x is equal to 1, the y value is 1. So we have to draw the straight line which goes through these 2 points. But I know this y equals minus x plus 2 is only valid when x is greater than 0. So this is valid when x is greater than 0. This is valid only when x is greater than 0. So this is not valid. Same thing when x is equal to 1, you get y equals 3, which means it's going through the point 1 and 3. It's going through this point, and the intercept is even 3. Then through the straight line which is going through these 2 points, but I know that it is only valid when x is less than 0. So you get y equals x plus 2 only when x is less than 0. So I told you when you have in a minus in front of the modulus, you will be getting the opposite of this V shape. So this is the graph of y equals 2 minus modulus x. So this is the graph of y equals 2 minus modulus x. Okay. Okay, hands up who got the answer. Good. Then do question. Then do this 16. To the question 16. So if there's any newcomer, like user, tutor of one of your friends today for now, when in the interval, you can go to the cashier and then tell that you are a new student. You will be getting 3 tutes. So then you can use that. For now, you can use a tute of a friend. And the online students, if you have any doubts regarding or any explanations that you want me to explain again, you can directly send a message in the chat in YouTube. I'll be checking it on and off. So you don't have to send any messages to the number that I have given before. Just use the YouTube chat. If you have anything, any problem related to today's class, any explanations, or if you want me to explain anything again, you can send a message. Question number 16, y equals 2 minus 2 times x plus 1. Y equals 2 minus 2 times x plus 1. Okay, write the definition. If x plus 1 is greater than 0, you get this one itself. It's 2 minus 2 times x plus 1. So when you simplify this, you get 2 minus 1. So it's 1 minus 2x. So you get this when x plus 1 is greater than 0, which means it's greater than minus 1. So that is the turning point. So this is what you get as the turning point, that x is greater than minus 1. And then when it becomes minus, You are getting this plus because minus minus becomes plus. Minus, we can write this in this way, which is not necessary. Minus minus, and then you get 2 plus 2 times x plus 1. So here you get 2x plus 3 plus 4. No? It's 2x here, no? Minus 2x. Because 2 cancel off, no? Yeah, 2 cancel off. So here it's minus 2x, and here you get plus 4. So that is when we got a negative term inside the modulus when x is less than minus 1. So these are the two straight lines that you're supposed to sketch. I got y equals minus 2x. I got y equals minus 2x and y equals 2x plus 4. So we know the intercept. This is 0 and this one is 4. Go with the turning point. So when x is equal to minus 1, you get y is equal to minus 2 into minus 1 is plus 2. So what do I get as the turning point? It's minus 1, 2. And here, when you substitute the turning point, x equals minus 1, you get y is equal to 2. So in this case, the turning point is minus 1, 2. The turning point is minus 1, 2. Okay. Okay, then let's sketch the graph. First mark the turning point. It's minus 1. And let's do with this one. It goes through the intercept 0. And when x equals minus 1, you get 2. When x equals minus 1, you get 2. So it's going through these 2 points. Sketch the graph that the straight line that goes through these 2 points, but I know it is only valid. This is only valid when x is greater than minus 1. When x is greater than minus 1, y equals minus 2x. And x1 is y equals 2x plus 4. The turning point is this and the intercept is 4. So mark 4. And then draw the straight line that is going through these 2 points, but I know it is only valid when x is less than minus 1. This is the straight line of y equals 2x plus 4. Clear? So this graph gives you y equals 2 minus 2 times x plus 1 modulus. So that's I told you, if you have a minus in front of the modulus, most of the graph that you will be getting this opposite of the typical V-shaped modulus graph. Clear? Okay, hands up who got this one. Good. Okay, so then do the next one, question number 17. So first write the definition and then draw the straight line that you know. You might get a strange straight line, that is okay, but draw the straight line you know. When you write the definition, you are getting y equals 2x, y equals minus 2x minus 1, and the other one is y equals 1. So forget about y equals 1. First row y equals minus 2x minus 1. Then let's think about the other one. Okay, so when you write the definition, you get x plus 1 minus x, which is 1. When x plus 1 is greater or equal to 0, means x is greater or equal to minus 1. Okay. And then you get the minus of this minus x plus 1 minus x, which gives you minus 2x minus 1 when x plus 1 is less than 0. So x is less than minus 1. Okay. So this is a normal thing that what I want you to follow in maths. Let's say in a problem that there are 2 parts you are supposed to solve and you know one part, but you are not pretty sure about the other part. අපි හිතමු ගානක parts දෙකක් තියෙනවා. එක part එකක් හදන විදිය හොයා දන්නවා, අනිත් part එක හොයා දන්නේ නැහැ. So what do normally students do? They are not thinking about the part that they know. They will be focusing on the part that they don't know. ඒවා බලන්න කරන්න බැරි එක දිහා බලනවා. So it's true that you have to focus on the part that you don't know. But before doing that, first complete the thing that you know. පුළුවන් දේ කරලා ඉන්න. That is the main thing. So before thinking or focusing on the path that you don't know, first do the thing that you can do. So first, so I admit you are supposed to draw a graph in this way that y is equal to 1. A different one, just forget about that. So first draw this one. So in that case, even though you won't be able to complete it, still you got half of the marks, no? The make and then you got 0 marks. But if you're going to focus on this, if you're going to draw this one, just keeping this away, then at least you can get half of the marks. Okay, so here I know the intercept. Go with the turning point, -1. You get y equals -2 minus 1, which gives you 2 minus 1. It's 1. So you have the turning point. When x equals -1, you get 1. Now draw this. The turning point is -1. So when x is less than this -1, when x is less than -1, you get this straight line that the intercept is -1. The intercept is -1, and when x equals -1, it's equal to +1. So you see that it goes through these 2 points. But I know this is only valid when x is less than -1. So in the way that I demonstrated previously, keep the ruler joining these 2 lines, but you know it is only valid when x is less than -1. So first do this. මුලින්ම දන්න කෙනා කරලා ඉන්න. Y equals -2x minus 1. And then look at the next one. It's y equals 1. So what is this y equals 1 graph? Now let's say you are going to substitute a x value that x is equal to 1. But there is no any x here. No? There is no any x here. So when you write y equals here, when we had x here, what we do, we substitute x equals -1. x කෙනෙක් ඉන්නවා නම් එතනට -1 දානවා. The method x කෙනෙක් නැහැ. So even when you put x equals 1, you get, okay, y is equal to 1. And when you put x equals 2, you still get y equals, the x equals 1, y equals 1. Then x equals 2, y equals 2. No, not 2. You still get 1. So it's clear, whatever the x value that you are going to substitute, your y value will be 1. So whatever the x value that you are going to substitute, your y value is equal to 1. So now think of that straight line. Whatever the x value that you are going to substitute, you are getting that y is equal to 1. So when x is equal to -1, still y is equal to 1. When x is equal to 0, still y is equal to 1. So if x is equal to 1, still y is equal to 1, because whatever the x value that you consider, your y value will be equal to 1. So when you draw a line, join in these points, you get a parallel line to the x-axis, and this is y equals 1. So you don't have to mark these coordinates. Y equals 1 is a line that goes through 1 parallel to the x-axis. It's a horizontal line. It's a horizontal line going parallel to the x-axis. So it is only valid after this point, after x equals -1, it is only valid. So this shape, which looks like an obtuse angle, is y equals x plus 1 modulus minus x. Clear? So y equals 1, I'll give a separate note. Y equals 1 is a line parallel to the x-axis, or a horizontal line going through 1. Because whatever the x value that we substitute, we get the y value is equal to 1. Clear? Okay, if you got the definition correct, that is okay. And if you have taken this, up to now it's good. But if you have done y equals 1 line in this way, it's really good. Hands up who got the y equals 1 line in this way. Good. Okay, so first note this down, and then let's write a small note. First note this down, everyone. Note this down, this straight line, which is a horizontal line. Okay, so then write note in a black pen, and in front of that, write this using a red pen. Write the word note in a black pen, and in front of that, write this using a red pen. Write this straight lines parallel to the straight lines parallel to the coordinate axes. Straight lines parallel to the coordinate axes. How do you spell axis? It's AXISES. No, AXES something. How do you spell it? Is it what I just wrote? AXI. Okay, sigaga inneva. Is it? No, not this. No. IS. It's ISIS. Yes. അതെ സിഗാണ്ടവാ അതെ stop. Like you are the English medium class, but not even sure about your dictation. Karena to odikali. It's ES. I told it. It's ES. So that's what I told in the beginning. That aparad. Okay. Okay. So this one. Silence. Huh? Okay. So stop. So it's clear when you have a graph. Katana. When you have a graph in the format of y equals a constant. So in the format of y equals k, let's say you have in y equals 1. It is a straight line, a horizontal straight line. That means parallel to the x-axis. So this is y equals 1. So if you take a -1, or if you go with here, it goes through 3. So this straight line, we name it as y equals 3. So when what can you say about x equals 1? So this is a horizontal line. What can you say about x equals 1? It's a vertical line. So whatever the x value you consider, no, x is equal to 1. So if every time, so when the equation is in the format of x equals a constant, you get a straight line parallel to the y-axis, the vertical one. So this one, if it is going through -2, you can say that the equation of this one is x equals -2. X equals -2. Okay, so in general, we can say when the graph straight line is in the format of y equals k or x equals k, we are getting straight lines parallel to the coordinate axes. If it is a y equals k shape, this is a horizontal line. If it is a x equals k shape graph, we are getting a vertical line which is parallel to the y axis. Okay, so you have written this note and this in a red pen and then write in a normal pen. Straight lines in the format of straight lines in the format of y equals k, y equals k are are horizontal lines parallel to the x-axis. Parallel to the x-axis. Next line. Straight lines in the form of x equals k, x equals k are vertical lines parallel to the y-axis. Parallel to the y-axis. Okay, then draw this and put the examples x equals 1, x equals minus 2, y equals 3, and y equals 1. And don't dare to talk, don't dare even to whisper. And then do question number 18. Start after sketching this, do question number 18. Okay, so when you write the definition, you get 2x minus 3 minus x. That is when 2x minus 3 is greater or equal to 0. So it's x is greater or equal 3 over 2. So when you simplify it, you get x minus 3. And when it is the minus, you get minus 2x minus x is minus 3x plus 3. And you get that when 2x minus 3 is less than 0, means x is less than 3 over 2. Now, what are the two graphs that you're supposed to sketch? One is y equals x minus 3, and the other one is y equals minus 3x plus 3. So you got the two intercepts. So find the other coordinate, use the turning point when x equals 3 over 2, or you get y is equal to 3 over 2 minus 3, which gives you minus 3 over 2, which means when x is equal to 3 over 2, you get the y coordinate, it's minus 3 over 2. So here even when you substitute x equals 3 over 2, you get y equals minus 9 over 2 plus 3. Even here you get the same result. Minus 9 plus 6 is minus 3 over 2. So when x equals 2, y is equal to minus 3 over 2. So always in modulus functions, so that I told you it's piecewise functions. So the turning points are the same. So wherever you stop from here, you will be starting the other one. So that's why we are getting the same turning point. Okay, based on this, sketch the graph. The turning point is 2x is greater or less than 3 over 2. So 3 over 2 is 1.5, no? Yeah, 3 over 2 is 1.5. So if I mark it here, 3 over 2, the turning point is it goes through minus 3 over 2. So it's going through this point, and we got a gradient of, sorry, the intercept of minus 3. So first row y equals x minus 3. The intercept is this, and it is going through this point. So keep the ruler joining these 2 points, and then it's clear, but it is only valid when x is greater than this turning point. When x is greater than 3 over 2, only this is valid. That means this is the straight line of y equals x minus 3. And the other one is you get the intercept of plus 3, the same turning point. It goes through this and mark the intercept plus 3. So then sketch the straight line that is going through these 2 points. Okay, so even it is going beyond this one, but I know it is only defined when x is less than this. So this is the graph of y equals minus 3x plus 3. And this graph is the modulus of y equals 2x minus 3 minus x. Okay, you then write a topic, not a main topic, just use a blue pen to write the entire topic. Intersection points of two straight lines. Write the topic, intersection points of two straight lines. Intersection points of two straight lines. Okay, so here the next topic that we will be doing is solving modulus inequality. So when you're solving modulus inequalities, when you're using the graphical method, we are supposed to find the intersection points of straight lines. So here I'm referring to the x coordinates of the intersection point because normally what we require is the x coordinate. So let's say I'm having one straight line and it is y equals x plus 1 and another straight line. It's y equals minus 2x plus 3. And I need to find this intersection point. So when it is a point, it should be both the xy coordinates, but here we are only referring to the x coordinate of the intersection point. So I need to find this point. I need to find this intersection point, the x coordinate of the intersection point. So when you have the x coordinate, you can easily substitute and get the y coordinate, but that is not necessary. What I want is the x coordinate. So it's a simple thing that you have to do. When you're supposed to find the intersection points between two straight lines, what you have to do is solve the equations of the two straight lines simultaneously. You have to solve the equations of the two straight lines simultaneously. So that is what you have to do. The easiest way that you can solve this, you got y and y. So when you make the first and the second equation equal because y and y, you get x plus 1 is equal to minus 2x plus 3. So you get x plus 2x is equal to 3 minus 1. You get 3x is equal to 2, which means you get the intersection point. It's x equals 2 over 3. X equals 2 over 3. So what is the intersection point? It's 2 over 3. So small thing when you're supposed to find the intersection points, and here we are referring to the x coordinate, and we know in other terms when you have the x coordinate, you can easily find the y coordinate by substituting it to the equation that we know. But when I'm solving modulus inequalities, you will realize this y coordinates is not necessary. You only have to know this x coordinate of the intersection point. Okay, so what we have to do, write the equations and solve them simultaneously. The easiest way to solve it is making the two y's equal. Is it clear? Okay, hands up if this is clear. Okay, then write in this way. To find the intersect, find the coordinates of the, find the coordinates of the, find the coordinates of the intersection point between two straight lines. Intersection point between two straight lines. Intersection point between two straight lines. We need to solve the equations. We need to solve the equations of the straight lines simultaneously. We need to solve the equations of the straight lines simultaneously. Okay, then do this example first, and then find the intersection point of this one. So first, do the example that I have done, even do the simplification alone, and then do the next one. Okay, so when you go to this example, the two equations are y equals 2x minus 1 and y equals minus x plus 2. So I told you the easiest way to solve this is making the first two equations equal. You get 2x minus 1 is equal to minus x plus 2. 2x plus x is equal to 2 plus 1. So that means I get 3x is equal to 3. So the intersection point is x equals 1. Okay, so this is the intersection point. You get it as 1. Clear? Okay. Then with the main topic of the lesson, modulus inequalities. For the main topic of the lesson, modulus inequalities. Modulus inequalities. Because we have done inequalities. So I told you a mathematical expression that is combined with an inequality mark is simply termed as an inequality. So when you have something like even x is greater than 1 is even an inequality, because a mathematical expression consists in an inequality mark is known as a inequality. So then a type of a inequality is this modulus inequality. Let's say that the inequality is consisting of modulus terms. The inequality is consisting of modulus terms. So we have modulus x is greater than 1. And then x minus 1 modulus is greater than modulus x plus 1. So the modulus can be in one side or in both sides. That is okay. And another one, I can get that 2 minus x plus 2 modulus is greater than modulus x plus 1 minus 3. So what are modulus inequalities? Inequalities consist in modulus terms are known as modulus inequalities. So there are two ways that we can use to solve a modulus inequality. One method is the graphical method. One method is the graphical method. The other method is the algebraic method, but we will be mainly focusing towards this graphical method. The reason is in the graphical method, you have to first sketch the graphs of the modulus functions. First, you need to sketch the graph, and then you will be using the graph to solve the inequality. So that will be our major focus area. The reason is if you look at the past papers, turn the last page. Last page means the past papers of the tute, not the last page of the basic algebra tutor. Last page under modulus functions. So if you are using the basic algebra one in the last page under modulus graph, modulus functions. So if you look at these questions from 2018, it's clear that they have given first you need to sketch the graphs of these ones. So draw the graph, draw the graph. So every question, even in 2024, first thing that you have to do is sketch the graph. And then only they are asking hence or otherwise. Okay, just I'm referring to the last page, 2023 A-level question. 2023. So look at this. In the same diagram, draw the graphs of these two. First, you need to use the knowledge of modulus graph and draw this. And then they have given hence or otherwise. So hence or otherwise means there is another method. We got the algebraic method. So even that is even accepted in the A-level syllabus. But the thing is that they have already asked you to draw the graph. So when you draw the graph, when you have already drawn the graph, using the graphical method is much easier because you have already drawn the graph. Even though you have the ability to use the other method, algebraic method, since they are asking you this, it's better. For example, I have told you this hence, like hence solving problems, hence or other ways. Then let's say in this way, you want to go to Boral. I have given this example, I think before. You have to go to Boral. And first you have been instructed to come to Nugegoda. You have been instructed to come to Nugegoda. And when you come to Nugegoda, and then you are getting the instruction, hence or other ways, come to Boral. Hence or other ways. So you have already come to Nugegoda. So you can easily go to Boral by taking one bus, so the train by 176, you can go to Boral. Nugegoda will liberai. But there are other ways. You can again go back to Kottav and then take this 174 bus and come to Boral. Or you can go to Fort, Kotuwada and Puluwang, and take a bus, this Rajagiri Kotu or something like that, and again come to Boral. So there are ways. But since you have already come to Nugegoda and you have got down from the bus, the easiest way is going in this hence route. Means you have come here and then you are using that. So even though the question says hence or other ways, we will be mainly focusing, or the major focus will be towards graphical method, because in every past paper question you are supposed to sketch the graph first. Is it clear? Okay, so under this one I'll be covering the graphical method, but later I'll be like briefly explaining what is this algebraic method, but the main thing should be graphical method. Okay, so what are modulus inequalities? The inequalities consist in modulus terms, modulus inequalities. And then I told you there are two main ways to solve modulus inequalities. The first one is the graphical method. Second one is the algebraic method. Okay. Right in this way, right in this way, inequalities consisting of inequalities consisting of modulus terms, modulus terms are known as are known as write in a black pen, modulus inequalities are known as, write in a black pen, modulus inequalities. Write these examples. You don't have to write the exact function, just write three inequalities consisting modulus. Okamaliyan don't. Just write three inequalities consisting modulus. Okay, and then write it this way. There are two main ways. There are two main ways to solve modulus inequalities. To solve modulus inequalities. And then write the two methods. The first one is the graphical method. First one, graphical method, and the next one is algebraic method. Graphical method and the algebraic method. Okay, then write the next main topic. Graphical method. Graphical method to solve modulus inequalities. Graphical method to solve modulus inequalities. Graphical method to solve modulus inequalities. Okay, keep the phone silence. Okay, I'll give you 1 minute, drink some water. And now if there's anything you can talk, but don't talk after this one. Okay, okay, no silence. Okay. So here we will be no silence. Using the graphical method to solve the modulus inequality. So I'll do question number one in the tute and the second set of questions. We are supposed to solve this inequality. So here, what we have to do when we are using the graphical method. The first thing is if you consider the expressions on beside these inequalities on the two sides of the inequalities, you can write them as functions. So this becomes y equals modulus x minus 1 and this is y equals 2. So if you consider the expressions on both sides of the inequality beside the inequality mark, you can name them as two functions. And then what you have to do is on a same coordinate plane, Cartesian plane, you have to sketch the graph of this and this. So that is what you have to do basically. You have to sketch the graph of this and this. So when you are sketching the graph, now you know how to do this. You get x minus 1 and minus x plus 1. This is when x is greater than, when you can write the definition directly, write it. It's better. So same thing what you have done so far, including last week. You are supposed to draw the graph of y equals x minus 1 and the graph of y equals minus x plus 1. So that you know. So I won't be spending that much of time to find the coordinates because we have done that before. You know the intercepts. And then if you go with this one, you get y is equal to 0. So then you get a turning point of 1, 0. And same thing when you put the turning point here, x equals 1, you get y is equal to minus 1 plus 1, it's 0. And then you get the turning point, it's 1 and 0. So then sketch the graph of y equals x minus 1 modulus. So when you're sketching the graph, always make sure that you name the straight lines properly. So here it's clear. We have drawn this before, so I'll directly draw this. The intercept is minus 1. And the point that I have marked, the turning point is 1, 0. It goes through this point. But I know it is only valid after this one. So here we got y equals x minus 1. And if you do y equals minus x plus 1, you get this in this way. That you know. So don't spend that much of time to find all the coordinates. If you can draw this in the same way that you have done before, just do it. So this one is the modulus graph of x minus 1. So what I told you, like you have to draw the functions that are in the both sides of the inequality on the same coordinate plane. So this is y equals modulus x minus 1. And then on the same plane, draw y equals 2. So that you know. Y equals 2, we just learned that y equals 2 is a straight line that is horizontal, which means parallel to the x-axis. So it goes through 2. So this is the first thing that you have to do. So I'll explain step by step. First thing is sketch the graph of the functions that are on the both sides of the modulus inequality on the same coordinate axis. It's clear. So same thing what we have done. Hands up if this part is clear. Small. Okay. Then write in this way. Write in this way. When using the graphical method, when using the graphical method to solve modulus inequalities, to solve modulus inequalities, the following steps should be followed. Or just like should be done. The following steps should be done. Following steps should be done. Another write using a star mark. So you should star mark write this. So write this in point wise. The first point is sketch the graphs. Sketch the graphs of the functions of the functions of the functions in the both sides of the inequality. Functions in the both sides. Oh, in the two sides. Two is more better. In the two no wait, both. In the both sides of the inequality. So what did I mention? Sketch the graphs of the functions in the both sides of the inequality on the same coordinate plane. On the same coordinate plane. On the same coordinate plane. Okay, then keep 5 lines and do the first example. Take this. So draw y equals, keep 5 lines, 5 rows. Keep it as a space. I'll be giving the remaining 2 points. So put number 1 and draw the 2 graphs on the same plane. Rule පහක් ඉඳ තියලා first question එක කරන්න question number 1. Okay, so the next step is after sketching the graph, we need to find this intersection points, the intersecting points. So when I say that you need to find the coordinates of the intersection points, I'm referring to the x coordinates. So now you have to find this one, these 2 points. So how can you find these two? So look clearly what are the 2 straight lines that have been intersected and then write the equations properly. So here y equals minus x plus 1, y equals minus x plus 1 and y equals 2 have been intersected. So you get minus x plus 1 is equal to 2. So 1 minus 2 is equal to x. So you get x is equal to minus 1. So I told you the next step is find the intersection points or the x coordinates of the intersection points of the straight line. So you get this one as minus 1. So you get this one as minus 1. And then the next one, find these intersection points. So clearly look at the equations of the straight lines. Y equals x minus 1, y equals 2. It's x minus 1 is equal to 2. So you get x equals 3. Okay, what is the other intersection point? That is x equals 3. Clear. So next point, next step is that you need to find the x coordinates of the intersection points. Okay, then come to the note again, put the second star mark, the next step. The previous note, not a new note, the previous note. Write this, put a star mark and write it this way. Find the x coordinates. Find the x coordinates of the intersection points of the intersection points between the straight lines of the intersection points between the straight line between the straight lines between the straight lines. We then find the 2 intersection points and mark them on the Cartesian plane. Okay, so you got the intersection points. Okay, so then this is the most important part. Okay, now look at the board, focus. This is the main important point. And when I ask you to raise the hands if you understood, and even then the online students will send a message after this one mentioning whether it is clear. And when you are watching the YouTube live, make sure you only send me a message if you are watching this live. Like if you are watching this with a 50-minute lag, don't send me a message. Yes, it's clear, because that's the thing when we do YouTube lives. I get some of the messages when I'm going home. Clear, sir. got it, and they are sending me the answer. So when it is a YouTube live, make sure you just reply or send a message if you are following the live exactly, yeah, without a lag. Okay, so now this is the most important part. What what should we find here? We need to find the range of x such that this x minus 1 modulus is less than 2. So what I have sketched here or drawn here are the graphs of y equals this and y equals this. So we are supposed to find the range that y equals 2 is greater than this one. We are supposed to find the range that y equals 2 is greater than y equals the modulus 1. So on this Cartesian plane or the coordinate plane, what do we consider that it is greater than? Now look at this. You can see the black colored line is above the blue colored line. So when you consider this range, you can see the black colored line is above the blue colored line. Which means, so the black colored one is this modulus function and blue colored one is this y equals 2. So it's clear this modulus function is above the y equals 2 straight line, which means this modulus function is greater than this. This is greater than this. So what do I consider as greater than? If the straight line is above this one, the straight line which is above is the greater straight line. So here we are supposed to find the region such that this blue colored one is greater. Blue colored one is greater. So we have to find the region where the blue colored straight line is above the black one. ඒ කියන්නේ නිල් පාට ඉන්න straight line එක කළු පාට එක්කෙනාට වඩා උඩින් තියෙන range එක බලන්න ඕනේ. We need to find the range such that this blue colored straight line is above the black colored one. But here, because greater than means it's above. Here it's clear. Okay, this one, the black colored one is above this, no? So the black colored one is greater. But when you consider the region after the intersection point, and now it is clear which line is greater. Tell me which line is greater, blue colored one or the black colored one? Other blue colored one. So the blue colored one is greater, which means that is great. It is above the black one. The blue colored one is above the black line, so it is greater. So in this region or range, it's clear that it is greater, greater, greater. But again, after this point of intersection, now again, the blue colored line is below the black colored line, which means the black colored one is greater. Clear? So we were supposed to find the range that this blue colored one. So why do I consider the blue colored one? This one, y equals 2. It should be greater than this modulus function. We were supposed to find the range that it is greater than this modulus function. So it's clear in this region, the blue colored is below. So it's not greater than, it's lesser than. But when you pass this region, when you pass this intersection point, it's clear in this region, the blue colored one is above the black colored one. The blue colored one is above the black colored one, which means it is greater than the black colored one, which means it is greater than the black colored one. Okay, now this is the range where the blue colored line is above the black colored line. So here above means it's greater than. උඩින් තියෙනවා කියන්නේ එයා ලොකුයි කියන එක. When it is going above, then that means it is greater. Is it clear that උඩින් යන part එක above? Okay. Then you can write your final answer. Write the inequality modulus x minus 1 is less than 2 when what is the region? Write this answer. X is greater than minus 1, but when it is less than 3. So then based on the region inequality, you have to write the range of x satisfying the inequality. Correct. ගන්න ලේසි මිතිය මං කිව්වේ බලන්න කවුද උඩින් යන්නේ. උඩින් යන එක්කලා ලොකුයි. So here this one is going above this. So it's greater. But we need to find where the blue colored one is greater. Okay, then again come to the note and put the last star mark. I ask you to keep 5 lines, 5 blank lines. So put a star mark and write it this way. Find the range of x. Find the range of x satisfying ing the given inequality. satisfying the given inequality. Satisfying the given inequality. Okay, then mark this one. So it's above the black colored one. The blue colored one is y equals 2. Y equals 2 should be above, should be greater than the modulus one. Should be greater than the modulus one. So mark this region and then write your final answer. Modulus x minus 1 is less than 2 when x is greater than minus 1 and less than 3. When x is greater than minus 1 and less than 3. If you got the idea, then do the next question. And students who have joined online, send me a message whether it is clear, or if you want any further explanation, you can mention it. So if this is clear, do the next question, question number 2. So you're supposed to sketch the two graph, y equals modulus x plus 2 and y equals 3. So when you're writing the final answer for the inequality, check what graph should be greater. So here greater means the graph that is going above. The graph below is less than. Okay, so sketch the two graphs. Y equals x plus 2 modulus. So you get x plus 2 and you get minus x minus 2. So it's when it is greater than minus 2 and when it is less than minus 2. So what are the straight lines you're supposed to sketch? The modulus, it's x plus 2 and y equals minus x minus 2. You got the intercept. So go with the turning point. So when x is equal to minus 2, y is equal to 0. So you get the turning point, it's minus 2, 0. And same thing with the other graph. When x equals minus 2, you even get y is equal to minus 2, which gives you 2 minus 2. So it's even 0. So then draw the modulus function. We have y and x. So the turning point is plus 2, sorry, minus 2. Turning point is minus 2. When x equals minus 2 is 0. So x plus 2, so you can directly draw the graph now. You will be getting a graph in this way, which goes through to the intercept. So this is y equals x plus 2. The other one is y equals minus x minus 2 going through the same point, and the intercept is minus 2. Intercept is minus 2. So when it comes from that point, it's in this way, but it is only valid when x is less than this, minus x minus 2. And the other one we have to draw is y equals 3. So you got 2, no? So then y equals 3 is a horizontal line going through this. So before thinking of the inequality, find the intersection points. So when you find the intersection points, this one, okay, what is that intersection point? Clearly look at the graphs that have been intersected. It's y equals minus x minus 2 and y equals 3. So it's minus x minus 2 is equal to 3. You get x is equal to minus 3. So this point you get x is equal to minus 5. And then this point, so look at the 2 points which get intersected. So this is one point of intersection, the x coordinate of it. And the next one is y equals x plus 2 get intersected with y equals 3. So x plus 2 is equal to 3. I get x equals 1 as the next intersection point. So there is something like after sketching this, it's clear when you are finding this intersection point, you are supposed to get a minus value. The make a hoyaddi එක minus value එකක් වෙන්න ඕනේ. Let's say when you are solving this and you get a positive value. So when you are finding this intersection point, let's say you are getting a positive value. That means your answer is wrong. It can't be because it's clear that it has been intersected in this minus one. So if you get a minus one, if you get a wrong answer, if you get a positive answer, that means either you have done a simplification mistake, එක්ක මොන හරි simplification එකක් වරද්දලා, එහෙම නැත්නම් if not, you have not taken the proper two equations. So let's say you are trying to find this point of intersection, but you take these two lines. So then you get x equals 1. So always keep in mind the graph is correct. If you are finding this intersection point, if it is clear that it is minus, you are supposed to get a minus 1. If you get a positive one, that means you have either done a mistake in your simplification or you have taken the wrong pair of straight lines. Okay, now you got these two. Okay, hands up who got this minus 5 and 1. Everyone got it. Good. And now look at this. We are supposed to find the range that the modulus is greater. So modulus is greater means modulus is this blue colored one. Modulus is the blue colored one. You don't have to use these two pens. Nilui kalui dekking and I'm just using it so then it is easy to explain. You just use the same pen or pencil. You don't have to use color pens, okay? So here the blue colored one should be greater. So should be greater means it should be going above this one. Clear? So greater, what do I refer to greater? Is the line that is going above. And now look at this. In this region, the blue colored one is greater than the black colored one. No? In this region, the blue colored one is greater than the black colored one, which means, okay, this is one region. In this region, it's clear that the blue colored is going above the black colored one. And then in this region, the black colored one is greater, because we are supposed to find where the blue colored is greater. Then above, after this intersection point, it's clear the blue color, the modulus function is greater. So after this intersection point, it's clear that this blue colored one or the modulus function is greater. So same as what we learned in inequalities, when there is a equality mark, consider this value. When you have the equality. And then you can write modulus, the final answer, modulus x plus 2 is greater or equal to 3 when, I write this answer, x is less than or equal to minus 5 or x is greater or equal to 1. You can write the answer that x is less or equal to minus 5 or x is greater to minus 1. Greater than or equal to 1. Okay, hands up who got that inequality. Consider these two sides. Good. So here now it is clear this inequality changes at the intersection point. No. So every time when we get an intersection point, the inequality changes. Here it's clear. The black colored one was below this one, or the blue colored one was greater. After this intersection point, the black colored one is greater. The blue colored one is less than that. And again after after this point of intersection, the blue colored one is greater. So every time you meet a intersection point, that means your inequality has changed. So intersection points are the points where the inequality will be changed. Okay, good. If you have taken the answer, even online students send me a message mentioning that you got the answer. If you have taken the answer correctly, mention it and then put a red star mark and write in a normal pen. Red star mark and write in normal pen. It is clear that at the intersection points, it is clear that at the intersection points, the inequality changes. It is clear that at the intersection points, the inequality changes. So when you are considering the logic of the inequality, every time when you get intersection point, okay, that means the inequality have changed. Even after here, you got intersection point, the inequality has been changed. Clear? No? Okay, then take a break and come by 5:45. The trigonometry unit papers have been kept out. You can take it. And like I think there were some Sinhala medium papers too. So like make sure you only take the English medium papers. Okay, write this. Okay, using a black pen, write note, and then in front of that, now don't do the same thing. Using a black pen, write note, and then in front of that, using a red pen, write this gradients of straight lines. Put a note in a black pen. Okay. Black pen, write node, and in front of that, using a red pen, write gradients of straight lines. Okay, so I know in O levels, no, don't make me. Okay, so in O levels, we have learned that the gradients of straight lines, and if you were supposed to find the gradient of a straight line, how did you calculated it? You took the difference between the y coordinates over the difference between the x coordinates. But when it comes to A levels, like we will be learning what is the definition of a gradient, but not in this unit. It will be done in the unit coordinate geometry. So that is a small unit that we will be doing in November. The coordinate geometry part. In that one, I'll be defining the gradient, I'll be giving the proper definition of a gradient. What is a gradient? But for now, you know the gradient. If I ask you what is the gradient, you will say the gradient is the ratio between the difference of the y coordinates over the difference between the x coordinates. But that is not the gradient. That is how you find the gradient. If you are supposed to find the gradient, calculate the gradient, you have to consider the difference between the y coordinates over the difference between the x coordinates. But I'll give you a small understanding. A gradient of a straight line refers the inclination of the straight line. The inclination, how inclined it is. So I'm saying if the gradient is increasing, the inclination is increasing. And in the other way, you know, like these gradients in this way, we say that those are positive gradients. So if the straight line is in this way, you get the negative gradients. So these are negative gradients and these are positive gradients. So now let's say we are having a straight line with a gradient 1. Here the gradient is 1. And now if I consider a straight line with a gradient 2, it's clear. I told you the gradient reflects the inclination of the straight line. So when the gradient is 2, now it has been increased. When the gradient is 2, the inclination should be increased. No? So that means when we have in a straight line with a gradient 1 in this way, if you are referring to a straight line with a gradient 2, that gradient, that straight line should be more inclined because the gradient reflects the inclination of the straight line. So this is m equals 2. And if you go to the minus side, like let's say we are having a gradient and this is minus half. So this is a minus gradient. And similarly, if you increase the gradient from the minus direction. So if this is minus half, minus 1 is more inclined. Minus 2 is more inclined. Minus 3 is more inclined. Even though like if you consider the numerical value of minus 3, that is less than minus 2. But that minus denotes that it is having a negative gradient. So if this is minus half, minus 1, minus 2, minus 3 gradients are in this way. somehow the inclination have been increased. So here it's, you can take this, okay, here the gradient is minus 1. So the gradient reflects the inclination of a straight line. So when the gradient, the positive gradient is increasing, the inclination is increasing in this direction. Similarly, when the negative gradient is increasing, the negative inclination, this increases in this side. Okay, I told you the gradient reflects the inclination of a straight line. Then what can you say when the gradients are equal? When the two gradients are equal, the two straight lines, the inclination is even equal. The inclination is even equal. So what do you call when the inclination of two straight lines are equal? Those are parallel lines. Clear? So when the gradients are equal, you get parallel lines. If I draw a gradient with m equals 1, another one, so these two are parallel. So it's clear if the gradient is equal, the two straight lines are parallel, which means those won't intersect at any point. Clear? Okay, so right in this way, we have written the topic gradients of straight lines, not the topic. Under that, right in this way, the gradient of a straight line, the gradient of a straight line, the gradient of a straight line reflects the inclination of the straight line. The gradient of a straight line reflects the inclination of a straight line. The inclination of a straight line. Okay, so then consider these examples. We have m equals 1, m equals 2. And if you go with the same gradient, the two lines are parallel. So I'll even mention that. For now, note down this. From here, it's minus. So the gradient minus 1. And if you consider minus 2, it's more inclined. If you consider minus 2, it's more inclined from the negative direction. So make sure these two are parallel. For m equals 1, m equals 1. Given after this, write in this way. Hence, it is clear. Hence, it is clear. If the gradients of two straight lines, if the gradients of two straight lines are equal, the lines become parallel. Or the lines are parallel. The lines are parallel. Okay. You now look at question number 3. I'll explain this because this is the way, this is now. Then I'm going to draw these straight lines only by using one point. So they can be straight lines. Ek point එකක් විතරක් පාවිච්චි කරලා. I'll tell you the reason why should we do this in this way. Now look at this question number 3. The inequality that I got is x minus 1 and x plus 2. Silence, no listen. So here first write the definition. Okay. First write the definition y equals modulus x minus 1. So when you write the definition, you get x minus 1 and you get minus x plus 1. This is when x is greater than 1 and this is when x is less than 1. So you're supposed to find, sketch two straight lines. One is y equals this and the other one is this. And again, take this coordinate plane. And now look at this. After I explain this, if you think this is a bit confusing, that is okay, just go with the normal method because I have already explained how to find 2 points and draw the straight line. That is, that you can do alone. That is totally okay. How to find the 2 points and then draw the straight line. Now this is what you have to do. Okay. Find the turning point. So what is the turning point? When you put x equals 1, you can even do that by like without writing anything. You can just do that. When x equals 1, this is a 0. So you have the turning point that 1, 0. Even this is the turning point 1, 0. So what I want you to do is consider the turning point that you have to find. So when you find the turning point, okay, it's 1, 0. This is the turning point. And how did you drive the straight line before? You consider the intercept and you put it as -1 and then you join these 2 points. So now this is what you have to do. Find one point, find the turning point that have already been done, and then you know the gradient is 1. So when you know the gradient is 1, it's a positive gradient. Just draw the graph in this way. It's a positive gradient. It's a positive gradient, so it should be in this way. And then name it as y equals x minus 1. Same thing, you're supposed to find this. I told you to find the turning point. It goes through this one. And then row y equals minus x plus 1. You know it is minus. When it is minus, the gradient is minus. The gradient is minus means draw a straight line going through this point with a minus gradient -1. When after you sketch this, you can show that the intercept is 1. Clear. So that's why I told you only by taking one point you can draw the straight line. Because normally in the past paper questions, like we are supposed to draw the rough sketch or the rough diagrams of these functions. So then you don't have to find all these points, mark them and draw this. It's just a rough diagram. So here, how did I do it? Find one point that should be the turning point. So I got this. From here, draw a straight line that is having a gradient of 1. Clear? That is having a gradient of 1. And the same thing, this is 1, 0. Okay, start from here. Draw a straight line that is having a gradient of -2. And I know that is only valid from this side. I know that it is only valid to this side. So that is done. What is the next you have to draw? Y equals x plus 2. Y equals x plus 2. Again, find one point. You can either find the turning point, or that is not necessary because turning point is only when you draw this one. You got y equals x plus 2. You know easily that the intercept is 2. So mark the point 2, which means the straight line is going through this point. Okay, now interesting thing. I told you, after finding one point, you can sketch the straight line because I know, tell me, what is the gradient here? What is the gradient here? It's 1. So then you need to draw a straight line going through this point, having a gradient 1. Going through this point, having a gradient of 1. Clear? So now look at this. The gradient of the line that I'm going to draw is 1. The gradient of this one, the gradient of this one is even 1, which means the two straight lines should be parallel. And now you got one point and the gradient of the straight line that you're going to draw is 1. Then you have this one, even the gradient is 1, which means you have to draw a parallel line, a line parallel to this. So draw y equals x plus 2, a line parallel to this one. So that means these two won't be intersecting again, and it is y equals x plus 2. So that is how, by using one point, you can sketch the rough diagram of a straight line. So this is how you do this. Okay, so find one point. If it is a modulus graph, make sure that you find the turning point, and then starting from here, you need to you need to draw. Focus. Look at the board. Not anywhere else. Okay, so here, starting from here, you're supposed to draw a straight line with a gradient 1, y equals x minus 1. Here, starting from this point, you're supposed to draw a straight line with a gradient -1. And then, when you're drawing the next one, make sure, okay, find one point. Easily you can get the intercept. So then draw the straight line, which is going through this point and parallel to this one. So now let's say, if the gradient here is 2, if the gradient here is 2, And here the gradient is 1, which means this line should be more inclined. No? This one should be more inclined. So then you have to draw this in this way because it's more inclined. Clear? Then you have to draw this in this way. Okay, now tell me if the gradient here was half, means the gradient is less than that one. So the inclination should be reduced. So the inclination should be reduced. When the inclination is reduced, there will be a intersection point. So that's why you need to make sure to draw the gradient properly. Look, if the gradient is equal, parallel lines, no any intersection point. Coach bar wage hambenne. If a rail track get intersected, that is only one time train. Coach bar kawadakat intersect වෙන්නේ. I mean the two lines of the railway. Coach bar වල දෙකක් can intersect. But the same line, the two sides are not getting intersected. If the inclination is greater than one, if it is like 2, do we have another intersection point? No. But if the gradient is less than this, that means this is the inclination is less. So then there will be another inclination point. So you have to make sure that you are drawing the graph straight line with proper gradients. If not, you will be missing the intersection points. Clear? You will be missing the intersection point. But let's say let's do this in this way. But after when you do 3-4 questions, you will be get used to this and you can easily do this. But let's say now it's a bit confusing for you. What you can do is you can do in the same way, find two coordinates, find two coordinates, find two coordinates and draw the straight lines. But even in that way, when you are drawing the straight line, make sure that these two should be parallel. And then you get the intersection points. So how can you find the intersection point here? What are the two lines that get intersected? Y equals x plus 2 and y equals minus x plus 1. So x plus 2 is equal to minus x plus 1. You get 2x is equal to minus 1. So what is the intersection point? It's x equals minus half. And now look at the inequality. You're supposed to find the range that the blue colored one is greater. No, the blue colored one is greater, not the modulus one. So here it's clear the black colored one is greater. Black colored one is greater, 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 greater. After this point, you can see after an intersection point, I told you the inequality changes. After this point, it's clear that the blue colored line is greater. So we need to find the range that such that the blue colored line is greater. It is x is greater than half. Then you can write the answer. Modulus x minus 1 is greater than x plus 2. When write your answer, x is greater than minus half. Okay. Hands up if you understood the method of sketching the graph or drawing the straight line using 1 point. Okay, so like if it is a bit like confused, it's okay. When you do 2-3 questions with me, you can easily get it. So why I need you to practice this? Okay, now this is the reason. So normally for A levels, we get this modulus graph question, modulus inequality as a first part question. Listen. You get this as the second question in your PU Maths paper. So it's 25 marks. So how do you get the 25 marks here? Make a 25 hambenne. For this one, for this straight line, you get 5 marks. For this straight line, you get 5 marks. For this, you get 5 marks. To find in the intersection point, you get 5 marks. To write in the final inequality, you get 5 marks. So how did you get the 25 marks? 5, 5, 5, 5, and 5. That means no any marks will be allocated for these parts. So even though you find 2 points each, you won't get any mark. Like if you're drawing these 3 straight lines, if you find 2 points each, you can find, but you won't be getting any marks. To write in the definition, you don't get any marks. So that's why I need you to gradually practice this one. You only get marks for the diagram, for the intersection points and the range. Clear? මේවා අර කරා කියලා අපරාධේ. කරන්න පුළුවන්. අපරාධේ. බොරු වැඩක්. ඒ කියන්නේ you don't get marks. And you don't get marks but වෙලාව යනවනේ. මේක කරන්න ගියපු වෙලාව වැඩිපුර ආයෙ දෙන්නේ නැහනේ. So you the time will be costed but you won't be getting marks. So like if you go like if you prefer this previous method where you were finding coordinates, for now do that in this way but slowly get used to this one. Okay, so then do this one question number 3 and then do question number 4. So if there's anything unclear you can ask from me. Then කවුරුත් කතා කරන්න බෑ same thing නා. I'm gonna කියන්න බෑ, don't even whisper. If there's anything unclear you can ask from me. Stop talking, do this one and then do question number 4. If there's anything unclear you can ask from me when I come. And online students, you can send a message in the chat mentioning if you want any more clarifications. After this, do question number 4. So I'll commonly explain some points that I got as questions from the class. So after that, do question number 4. Now, so if you have completed this, do the next question. එච්චරයි කටවහන් කරන්න. මලකට ආවනේ. මලකට ආවම තිබ්බ නැති ප්‍රශ්නයක් ගියාට පස්සේ තියෙන්න බෑ. There can't be any question that you didn't have when I came near to you. Okay, so here are some questions that they had. So here, how did I take this one? Is the same thing that I did to find the turning point. So if you are drawing, like if you are sketching this graph, I told you to find the turning point. No. So how did you find the turning point? I considered x equals 1 and silence. 0 noise. I consider x equals 1 and then I get y 1 minus 1, it's 0. So that is how you got this 1, 0 coordinate. So even here, when you do it, you get the same thing, 1, 0. So that is what I have written as 1, 0. So that was one question. The other question is to find the intersection point. Why did I consider these two equations? So it's like this. We need to consider the equations of the straight lines that are intersecting. So look at the straight lines that are intersecting. This is y equals x plus 2. What is this straight line? It is y equals minus x plus 1. Minus x plus 1. So that's why I have considered only these two. So here, this one is not there because y equals x minus 1, that doesn't get intersected. So only consider the straight lines that are intersecting. And then the other question was, how did I mark 1? So I told you I didn't want this 1 when I drew the straight line. I got that the turning point is 1, 0 and the gradient is minus 1. So it goes in this direction. That is clear. But after you sketch it, it's clear that the intercept is 1. So that's why I put this as 1. But you didn't want this intercept when you drew the straight line initially. And this one, how did I get this final answer? Is look at the range that this blue colored one, this straight line, x plus 2, is greater than the modulus 1. So in this region, it's clear that the black colored one is greater. So what do I refer as greater, which goes above? So this one is this one goes above, this is greater. After this intersection point, it goes below. The blue colored one is now above, which means the blue colored one is greater. It's clear from here onwards because there are no any intersecting points. So if there are no any intersecting points beyond this one, the inequality does not change. Clear? Throughout this one, it will be the same one. The inequality changes only when we have an intersection point. So from here, till infinity, the blue colored one will be going above the black colored one. Okay. So then I ask you to do question number 4 when you are. Okay, any questions? Not yet, no? Okay. Then question number 4, x plus 1 is modulus greater is less than Where can we draw that? Let's go to the question number 4. Modulus x plus 1 is greater than 2x minus 1. Greater or equal? We have an equal mark. Great. Okay, so here now first thing you have to sketch this one. Y equals x plus 1. මේ අනිත් එක when you asking questions like question එක ආදී ඒක ගොම් ප්‍රශ්නයක්ද කියලා හිතන්න එපා. If you are having a doubt, just ask it. Whatever the question you got, like when you are online student, there is a body අවුලක් තියෙනවා when you put it in the chat. But that is even okay. But if you have any doubt, even when you're sure, like not sure how did this happen, you can ask it because like at the initial period of your A level, don't have any doubts. Later, or when you have doubts, you get used with that, and then you get used. You are going to ask it from a friend, and then somehow you can manage. But initially, when you move forward with doubts, it reduces your confidence to the subject. So any small question, like I'm here to explain that. So if you are not clear, just ask it. Any small doubt. You might think that is a silly question. That is okay. So what are the two lines x plus 1 and minus x minus 1? So this is when x is greater than minus 1 and this is when x is less than minus 1. So what are the straight lines we need to sketch? Silence. Y equals x plus 1, y equals minus x minus 1, and the other one is y equals 2x minus 1. So I told you to how to take the turning point. It's in this way. The turning point is minus 1. So when you put x equals minus 1, it's minus 1 plus 1. Got it? So then you can find it, it's 0. Or else you can do the same thing that you have been doing since last week. If x equals minus 1, you get y equals 0. So you're having the turning point of minus 1, 0. So this is up to your simplification. If you are okay with the simplification, you can directly write this. You can directly write this. And even here, when it is x equals 1, sorry, minus 1, it's clear. You get 0. Because I told you, you won't be getting marks for these ones. So better if you can directly write it, but still okay. If you want to find it separately, do that. Okay. So then, what we got is the turning point is minus half, minus 1, minus 1. And we need to draw y equals x plus 1. So that's all. This is all. You know that it goes through this point. Draw a straight line that is having a gradient of 1. So when you are like drawing the first straight line, you don't have to think about the gradient. Or පළවෙනි straight line එක අඳිද්දි හිතන්න ඕනේ නැහැ මේක පල්ලෙහෙන්ද උඩින්ද, you don't have to worry about that. Just freely draw a positive gradient. That's all. In the first one, just draw a positive gradient in, like you don't have to think about the inclination. Okay, this becomes y equals x plus 1. So after writing it, it's clear that the intercept is 1. Now, is it clear? Like how did I mark this plus 1? Because I didn't wanted that plus 1 to draw this straight line. But when I have written the equation, I can see the intercept is this. Same thing with this one. You are supposed to draw this minus x minus 1. Then started from this point, just draw a minus gradient. Don't think about the inclination. So why do I mention that don't think about the inclination? Okay, now we are going to draw the second one. Y equals 2x minus 1. So you can easily, I told you 1 point should be found. So what is the point you can easily take? What is the point you can easily find? The intercept. The intercept here is minus 1. Okay, now I'm going to draw a straight line that goes through minus 1. Okay, now look at this. So I told you, when you are drawing the first straight line, you don't have to consider about the gradient. But when you are sketching the second straight line, දෙවැනි එක්කෙනා දෙද්දී, and now you know, here the gradient is 1 and here the gradient is 2. So when you are drawing this one, it's okay even you take this in this way. එමයි කියලා ගොඩාක් වැඩි කරන්න එපා. So when you increase the gradient up to here, ඊළඟ එකේ gradient එක අඳින්න වෙන්නේ කෙලින් උඩට. අර ගොඩාක් වැඩි කරන්න එපා. So just keep it in here. And then when you are drawing this one, now you know the gradient is 2, which means the inclination should be greater than this. Clear? So that's the thing that you need to consider. A gradient is greater than this one. So there is the intersection point. So you can get the intersection point when you make these two equal. Okay, now look at this. What are the two straight lines intersecting? Y equals 2x minus 1 and y equals x plus 1. So 2x minus 1 is equal to x plus 1. It gives me x is equal to 2. Okay, then I got the intersection point as x equals 2. Okay, this is x equals 2. And then look at the inequality. You're supposed to find the inequality. This is correct? No, this other side. Correct. Okay. You have to find the range such that the blue colored line is greater. So this one, you can see the black colored one is above. No, the black colored one is above the blue colored one. We make the black colored one is above the blue colored one. Above. Hariyanne. After this intersection point, it's clear now the blue colored one is greater above the black colored one, which means it is greater than this. So after this range, it's clear that this is greater than this. So then you can write the inequality. Modulus x plus 1 is less than 2x silence when x is greater than 2. Okay. Hands up who got this. Okay, good. Then do the next one. Question number 5. Can you join online? Can you send a message mentioning who got the answer? Okay, so what do we have? Y equals, modulus 2x minus 1 is greater or equal to x plus 1. We have modulus 2x minus 1 is greater or equal to x plus 1. So then write the definition. Y is equal to this. So then you get 2x minus 1. Now you are okay to write the definition directly because we have been writing this since last week, no? So what are the straight lines you're supposed to sketch? Y equals 2x minus 1, y equals minus 2x plus 1, and y equals x plus 1. So same thing that I mentioned before using the turning point. When you put x equals half here, you get 0 that you can, okay, I'll just do the simplification. When you put x equals half, you get y is equal to 0. When you get the turning point, it's half 0. And here, the same thing, when you go with x equals half, y becomes 0. So then it is half and 0. So what is the modulus function? Then you can draw this in this way. Where we have a turning point of half 0. This is half. And now I know the gradient of the straight line I'm supposed to draw is 2. And you know the gradient of the next line will be 1. So it's better if you can take a greater inclination because the next one will be 1. So when you are drawing this, mark this point, the gradient is 2. So then it's in this way. Y equals 2x minus 1. The other one is y equals to minus 2x. Y equals minus 2x plus 1. Okay. And then go with y equals x plus 1. I told you the easiest point to draw is mark is the intercept. So intercept is 1. So it's in this way. But make sure the gradient here is less than this. So it should be less than this and it will be going in this way. So we are getting two intersection points. One intersection point, it's clear, it's 0. And then you need to find the other intersection point. First find the other intersection point and then you can go ahead with the logic. Okay, so this is y equals x plus 2. So I told you when you're x plus 1, when you're finding the intersection point, make sure that you are taking the proper equations. So what are the straight lines that have been intersected here? Y equals x plus 1 and y equals 2x minus 1. So when you make them equal, you get 2x minus x is equal to 1 plus 1 and x equals 2 is the intersection point. X equals 2 is the intersection point. And then look at the inequality. The modulus should be greater. Kalu part ekkena. Kalu ekkena neme kalu part ekkena. The black colored one. Black colored one should be greater. Okay. මොකද එහා පැත්තේ කළු හින්දාද බලන්නේ? එහා පැත්තේ ගියා බලන්න. හරි. Okay, so here the black colored line should be greater. A black colored one should be greater. So in this region it's greater, greater, greater. Until this intersection point it's greater. Again, the black colored one is greater. Till this point it's 0. It's greater. When it is moving above, that means it is greater. This range, the blue colored is above, which means the black colored is less than that. Again, after this intersection point, you can see the black colored one is greater. So these one should be colored. So then write this one, okay, 2x minus 1 is greater or equal to x plus 1. When write the inequality, what is the inequality? X is less or equal to 0 or x is greater or equal to 2. So you're having two ranges in this side and this side. You got the answer? No, hands up who got the answer. Everyone's supposed to get. Wait, hands up who got the answer. Good. Then do this question, the 1992 A-levels question. 1992. You were not even born, no? No, I was not even born. Question number 2 on the past papers, 1992. 1992. Do it alone. So this is the first past paper in modulus graph that we will be doing. So do it alone. So always make sure to consider the gradient. 1992 A-levels, second question in the past papers question. So the two gradients we have to compare is 2x and 3x. So when you are drawing this 2x or gradient 2, make sure like you will be having a straight line with a gradient 3. The inclination එක ගොඩක්ම වැඩි කරන්නත් එපා. මොකද ඊළඟ එකේ gradient එක 3යිනේ. Okay, so we have 1992 under the past papers. It's 2x minus 1 modulus. It's greater than 3x plus 5. Greater than, no? Yeah. So then what are the graphs that you have to sketch? Y equals 2x minus 1. The modulus. Okay. Yeah, and the other thing, like, let's say, without even writing this definition and all, a student will be directly drawing this modulus graph half, this 2x minus 1 in this way, without even writing the definition. If you can write this, if you can draw the modulus graph in this way, that is really good. Because I told you, you won't be getting any marks for the definitions and finding the points. So if you can draw this directly, It's really good, but I'm not expecting this to do today. But next week you can do that based on your experience for the today, like based on the experience today and last week. If you can directly draw this, that is really good. Because at the end you will be getting marks only for this one. Okay, for now, but I'll just write the definition and all. But let's come to a stage at least in the fourth week, last day of the lesson, where you can directly draw this in this way. So how did I get it? I get 2x minus 1 when x is greater or less than half, minus 2x plus 1 when x is less than half. So what are these straight lines I need to sketch? Y equals 2x minus 1, y equals minus 2x plus 1, and y equals 3x plus 5. Okay, so y equals 2x minus 1. If you, the same thing? Yeah, it's the same thing. So since it's the same thing, I'll write the turning point half 0. So that's how I mark this point. It goes through this one with a gradient 2. So I told you when you are drawing the first straight line, don't think about the gradient. Because you don't have to consider, you don't have to worry about the gradient because this can be any gradient, any positive gradient. But make sure when you are taking the second line, its intercept is 5. We got the intercept is 5. So here, after getting this one, it's clear that the intercept is 1, okay. And now you are having a straight line with a gradient 3. If the gradients are equal, this is parallel. In case if the gradient was less, then it is going in this way. We are having another intersection point. Clear, we are having another intersection point. But here the gradient is 3, which means it is going in this way, where there is no any intersection. Okay, this is y equals 3x plus 5. So find the intersection point. I'll take it. So I'll trust you. What is the intersection point? Minus 4, 5. No? Yeah, you get minus 4, 5. And then the modulus, modulus should be greater. The modulus should be greater. The modulus is the black colored one. It is above in this region. So this one, it's above, greater. It's above the blue one. But after this one, soon after you get a intersection point, the inequality changes. Then the blue colored one will be greater. So this is your inequality. You can write a modulus 2x minus 1 is greater than 3x plus 5 when x is less minus 4 5. You're getting the answers. Okay, hands up. Let's see who have taken. Okay, so let's do one more question. Do the 2014 question. 2014 question number 15. Okay, silence. Sadhanathan. Okay, to the Kadhanathan. 2014 question number 15. Okay, so here you're supposed to prove y equals x plus 1 modulus. You get x plus 1 and minus x minus 1 when x is greater than minus 1 and less than minus 1. So you're supposed to sketch 3 straight lines. One is y equals x plus 1. Other one is y equals minus x minus 1. And the other one is y equals 3x plus 7. The intercept is 7. So find the turning point by substituting x equals minus 1. Minus 1 plus 1 is 0. So it's minus 1, 0. You get the intercept, the turning point. Sorry, the turning point as minus 1, 0. Even here, when you put minus 1, minus is plus. You get 1 minus 1 is 0. It's minus 1, 0. So take the turning point as minus 1, 0. So it's more towards the positive side because we are supposed to mark a plus 7 gradient. Okay, the turning point is -1, 0. It's going through this point. And draw the graph with a positive gradient 1, which goes through this. Name it as y equals x plus 1. So when we were drawing this initially, I didn't want the intercept, but later you can mark it if you want. The intercept is 1. So even the next one is going through this point, and it's y equals -x minus 1. So when you mark the next straight line, it's y equals 3x plus 7. It's clear that you can mark the intercept as 7. So here, not like in O levels, I even mentioned that before. If you take this, like let's take you are taking one line as 1 unit, then you don't have to mark 7 exactly at 7 units. You can just take it roughly because these are rough diagrams. These are rough sketches. Like let's say you are taking one, you are marking one as 2 lines. So then your 7 should be after 14 lines. These are not graph papers. So all are rough diagrams. So if you mark one in here, you don't have to check how, like, where do you get 7. That's okay. Just take a considerable height and mark it as 7. And here the gradient is 3. So it should be greater. It should be greater. And it's going in this way. So here we got intersecting point y equals 3x plus 7. Okay, find the intersection point and make sure that you have taken the proper equation. So what are intersecting? Y equals -x minus 1 and y equals 3x plus 7. So this is equal to -x minus 1. You get -1 minus 7. So 4x is equal to -8. You get the intersection point as -2. Is it -2? Okay. So you get this point of intersection, the x coordinate of the point of intersection as -2. As -2. So this is, wait, not this. The point of intersection is -2. And then let's see the inequality that they are. Don't get ready to go till I ask you to get ready. Yeah. Then look at this inequality. You are supposed to find where this modulus is greater. Araka minus same as this previous one. The modulus means the black colored one is great. It's clear. This is above. The black colored one is above. Which means in this region, the black colored one is above this. And then when it passes this intersection point, you can see the blue colored one is greater. So this is the region. So write the final answer. Modulus x plus 1 is greater than 3x plus 7 when x is less than -2. Okay, hands up who got this one, the last answer. Like even online students mentioned where they took the answer. If you have completed, you can get ready to go. Okay, okay, silence. So if you like, okay, if your trigonometry paper was not there when you checked it, I'll just check it again because one panel member was missing. Was missing means he hasn't come today. So you can collect the paper next week. Yeah. So then I have upload. I won't be doing it. I'll will be doing the discussion probably this week because still we didn't give the silence. Still we didn't give the papers to the single medium students. So when the papers are given to them on Saturday, I'll do the discussion of the trigonometry unit paper. For now, you can go through the marking scheme. I have uploaded the paper and the marking scheme in the group. Clear? Okay, so that's all. We are done for today. You can go home safe.